Question 7, Part A. Anne and Kay are employed by an accounting firm. Anne accepts employment with an initial annual salary of $50,000. In each of the following years, her annual salary is increased by $2,500. Kay accepts employment with an initial annual salary of $50,000. In each of the following years, her annual salary is increased by 4%. Part 1. What is Anne's annual salary in her 13th year? Since Anne's salary is going up by the same amount each year, $2,500, we can model this situation as an arithmetic series where the first term is $50,000 and the common difference is $2,500. So the series is $50,000 for the first year plus $52,500 for the second year plus $55,000 for the third year and so on. Now we want Anne's salary in the 13th year. Using the formula, Tn, or the nth term, is equal to A plus n minus 1 in brackets times D, where A is the first term, which is $50,000, D is the common difference, which is $2,500, and n is 13. So T13, or the 13th term, is equal to 50,000 plus 13 minus 1 in brackets times 2,500, which equals 80,000. Therefore, Anne's annual salary in the 13th year is $80,000. Part 2. What is Kay's annual salary in her 13th year? Kay's salary is increased by 4% each year. Whatever her current salary is, the following year will be 4% higher. So in other words, whatever her current salary is, if we multiply that by 1.04, we'll get her salary in the following year. So we're going to model this situation as a geometric series where the first term is 50,000 and the common ratio is 1.04. So the series is 50,000, this represents her salary in the first year, plus 50,000 times 1.04, which represents her salary in the second year, plus 50,000 times 1.04 to the power of 2, and so on. So using the formula, Tn, which is the nth term, is equal to A times R to the power of n minus 1, where A represents the first term of the series and R represents the common ratio. In this case, A is 50,000 and R is 1.04. We want to find T13, which represents Kay's annual salary in the 13th year. So T13 is equal to 50,000 times 1.04 to the power of 13 minus 1, which equals 80,051.61093 and so on. So rounding this to 2 decimal places, because it's a dollar amount, Kay's annual salary in the 13th year is $80,051.61. Part 3. By what amount does the total amount paid to Kay in her first 20 years exceed that paid to Anne in her first 20 years? The question is asking for the difference in the total salaries paid to Kay and Anne over a 20-year period. Now, Anne's total salary over 20 years is found using the sum of an arithmetic series formula. Sn, which represents the sum of the first n terms of the series, is equal to n over 2 times open bracket 2a plus n minus 1 in brackets times d, close brackets, where a represents the first term of the series and d represents the common difference. We have S20, which represents the sum of the first 20 terms of the series, is equal to 20 over 2 times open bracket 2 times 50,000 plus 20 minus 1 in brackets times 2,500, close brackets, and that evaluates to 1,475,000. Now Kay's total salary over 20 years, using the sum of a geometric series formula, Sn equals A times 1 minus R to the power of n in brackets, divided by 1 minus R in brackets. We have S20 is equal to 50,000 times open bracket 1 minus 1.04 to the power of 20 close bracket, divided by 1 minus 1.04 in brackets. And that evaluates to 1,488,903.929. So the difference in salaries is 1,488,903.929 minus 1,475,000, and that equals 13,903.929. We need to round this value correct to 2 decimal places because it represents a dollar amount. Therefore, Kay's total salary over 20 years exceeds Anne's by $13,903.93.